Hmm? My video. Oh, nah, definitely not. I'm not that pretty. So good evening, welcome. Tonight I'm going to be talking about just an introduction to durable functions. Why is it not going? All right, we'll do it that way. So kind of for an agenda tonight, I'm just going to first do a quick introduction overview, like what durable function is. We'll go into, that'll be pretty short. We'll start going into building your first orchestration, talk about a couple different patterns and how you can use it. This is really going to be designed to be quick introduction to it, a little bit of code. I'm going to try and do live demo. If I can't, I'm going to switch to code that I put on in my GitHub. So everything tonight you'll be able to download yourself. And then we'll just kind of close the night out. So a little bit about myself, like Zarella said, I actually hit just a little over 25 years working with Jackson National Insurance. Currently, I'm always trying to strive to learn new things. Right now, I'm kind of in this don't learn too much more about my career. I'm into doing a little things outside, and so right now that's technical diving. So just getting ready to start doing deep technical diving, decompression, nitrox, or not nitrox, but Trimix, CCR. That's my goals for this year. So also a private pilot as well. So I just have a lot of fun. Right. So what is a durable function? Durable functions is an extension of Azure functions. So you've heard Azure functions. Those are serverless functions. They allow us to just write stateless API calls. The durable function framework extends on that model and then allows you to write stateful workflows. So turning those things from something that just runs stateless all the time into something that's stateful. It's broken up into orchestrations, activities, which does your actual I/O, so making calls out to other APIs and actually doing the meat and potatoes of what you're trying to orchestrate. It also, under the covers, manages all the state for you. So your main focus is to actually just define what you want to orchestrate and actually do the work, not go call the database to make sure that all this stuff actually works. Durable functions is actually an extension. Since Azure functions can be written in multiple languages, they've also created this framework so that it works on multiple languages. So it runs on C#, it runs in Java, it runs in Python, it runs in JavaScript, it runs in TypeScript, it runs in PowerShell. So all of those various languages you can also automate in the same similar fashion as you will with this extension library. One of the things about this is there are low-code, no-code solutions to do this same thing. So in the closest one would be Azure Logic Apps to this. Low code, you don't have to write too much, but what my personal dislike is around testing, it's around control, it's around also, since it's low code, they're changing the framework and code underneath. And so sometimes that code gets broken and you didn't even do anything to break it. So just kind of a real quick glossary. I'm just going to go over a couple of the words that you might hear. So a deterministic function. This means that whenever we take an input and we call a function, that function is always going to return the same result given that same input. Okay, so like if we were to think about like a function x plus 1 and we pass in 5, we always expect 6. If it's non-deterministic, we can't expect the results to come out the same way. One of the important foundations of how this works is the orchestrations themselves have to be deterministic. So you'll hear me kind of repeat that over and what that means, and we'll talk through it here in a second. A client. So really in Azure Functions, everything is run by a trigger. So the client is really just the starting point by which we start an orchestration. So anything that we can use as an Azure function trigger can then take this client and say, go run an orchestration. So the client is something that gets passed in as a binding parameter, and then you're able to start or send commands to the orchestrator. The orchestration itself, it just orchestrates what you want to do. So you may think of something like taking, I want to drive to the store and break that down into smaller portions. You might say, get in the car, drive to store, enter store. Instead of saying, now you're taking out and doing very high level functions. We're not just saying like, oh, but I walked to the car and I navigated and I went through these hallways and I opened the door to my car. So we're thinking very, very high level. Activities, however, are the actual things that we do. So that is I'm going to walk to the car and get in the car. I'm going to drive to the store, and then I'm going to get out of my car and go into the store. So think high level process. What is it I want to do? And then how am I going to do it is the activity. Does that make sense to everybody? Cool, awesome. So if we kind of look at how this looks from a visual perspective, you can see here that we have the client, which is going to be our trigger. So it could be an API, it could be an event that we get from like event hubs, it could be a webhook, it could be any number of the triggers that are available as input triggers to Azure Functions can call that client. And then the client starts an orchestration. So any data that we may get in during that trigger, we're going to pass to the orchestration, because maybe we need to say like, hey, I want to do that process of driving to the store. And then the individual activities are the things that do the execution. So this might be like calling my APIs, sending emails, etc. Make sense? Awesome. So here might be an example orchestration. It's actually one that I'm going to do the part of my demo on towards the end. So this orchestration is a very simple simulation of what you might do when you place a order at Pizza Hut, right? We have this one website, which is Pizza Hut for all of the stores that exist. And I want to go online and place an order to order my pizza. You may have actually seen a process that looks just like this. I go in, I place my payment and every information, and at one point you get this message that says, please wait, don't refresh this. We're sending the order to your store so that it can start making the pizza, right? But wait, how are they going to tell us when the pizza is coming to my house? I can't just like send it to the store and say, hey, it's coming to your house. It's going to take time, right? Somebody's got to actually make the pizza. So as part of that process, we want to send it to the pizza maker. So we have Super Mario Brothers pizza store here, and he only makes one pizza at any given time. Everyone is very special and made to order. But as soon as he is done making your pizza, he clicks a button that says your pizza's made, and the rest of this process continues, which sends out a notification. Maybe it's to my phone or an email or whatever my preferences are. The act of having a story in which here are some things that need to happen is the what, right? What do I want to happen? How I execute that, like send the order to the store, might be go contact my POS system, enter the stuff into it, and show it up on the screen, right? So then Mr. Super Mario there, he goes and says, oh, I gotta make a pizza. And then so basically now he starts making that pizza and then he clicks the button. That system then contacts our orchestration again and says, I'm done. Perfect. Now let's send the notification out. Okay, so that's going to be our orchestration, and those little squares are going to be our little activities that we want to orchestrate. Does that make sense? Awesome. Any questions so far? Perfect. All right, so let's start looking at some code. No. Yeah, I think it's because it's still on. I just need to stop. I can't get it back though. There it goes. There we go. Everybody able to see that? All right. So for the first demo, I'm going to just show like how to get started. It's actually pretty simple. So I'm using Visual Studio 2022 Enterprise, but this should work all the way down to Community Edition. One of the important parts is you're going to add the durable function. I think it actually might come standard now, but so you'll have to look at like some tutorials at how to get that extension added to Visual Studio. I'm just going to show you after that point. So I'm going to create a new Azure function. So we'll just call it function app demo. Yeah, function app demo 1. And right now I'm just going to do a .NET 6 isolated. That's basically like current technology. .NET 8 is just now coming out, but the durable functions is kind of like not quite there. So I would recommend that we start with .NET 6. You can also still do it in process mode as well. They're going to stop supporting that here before too long, just because the isolated process is their future state. One of the important parts is that I am going to use Azurite for my storage account. This requires a storage account underneath the covers. I mentioned how it maintains state. So it uses a combination of table storage, blob storage, and queues in order to orchestrate all of this and make it so that the workflows just magically work for you. So I'll just make sure that that's turned on for now to emulate a storage account. Everybody can hear me okay, right? Okay. All right. So I'm going to go ahead and just start that real quick so we can just make sure that everything's loaded and working. And this is the part where I'm nervous and going, oh no, I'm going to have to switch back to the other one and show you how it works there. Yep, that's what I was worried about. Okay, there were build errors. All right, so I'm going to flip back over here. with me 1 second. One and one. Okay, perfect. And actually, I should have just picked this one first. I already have the code for an orchestration in here. I'm just gonna make sure it runs one more time just to be sure. Perfect. Okay, cool. So had this part built right, I would have been able to just run this, and then I would have ended up with a screen where it ran just like you just saw. So it would have something that looks like this. Do it again. There we go. And we would have had just this top function up here. I didn't change anything. So I'll just show you like the code that it produces since some people are new to this. And then just to show how easy it is to get just a simple Azure function running, and then I'll show the orchestration on top of that. All right, so the code here we would have ended up with is right here. It's just a simple function that just says, welcome to Azure Functions. So if I call this, it's gonna execute that function and return that to our browser. And I'll do it again, just to prove that it's working. And come on. So if I just do a quick get to it, wahoo, welcome to Azure Functions. Amazing, right? Okay, so that's just getting in Azure Functions set up in just a few short minutes. Now we're gonna go to doing our first orchestration. So in order to do that, now that I have my function app running, I can do add new Azure function. We're gonna give it a name, and I'm gonna call it new orchestration hello. And we're gonna say add. And so as part of doing this, we're gonna scroll all the way down here to the bottom. There's this one called Durable Functions Orchestration, and we're gonna pick that. And so now magically, we have some code that's been written for us and starts our very first orchestration that we're gonna be able to do. What this orchestration does, so if you remember, there was the first part, which I said is the client. That's this part right here, the new orchestration, HTTP start. So this is when I call this function via my API, it's going to call my orchestration, new orchestration hello. So we're gonna now look for new orchestration hello. Oh, just so happens there's a function named new orchestration hello. You'll see that it has run orchestrator as its default method name, and it has this task orchestration context. I'm not going to get into that just quite yet. What we can see that it does, though, is it logs some information. I'll get back to this replay part here in a minute. And then does three things. It says, go and call an activity named, say hello, and pass an input of Tokyo. And it's gonna wait, and it's gonna try and get that string value and place it in this outputs list. It's then gonna do the same thing, calling say hello, but this time with Seattle, followed by London. Makes sense what that's doing? So this is just a sequential workflow. Do this, then this, then this. Our activity right here now expects that name that we're passing, the string that we're passing in, and it's just gonna log that says, hey, I'm getting ready to say hello, and then it returns the value of hello name. So the string that I'm going to get back on the other side is just that. When the orchestration is completed, it's going to combine all those results. So it's going to end up saying, hello Tokyo, hello Seattle, hello London. Makes sense? So while normally in our code, like in an API, we would have combined that function and we would have called the function directly, we're now calling it indirectly. And the reason why is because the framework is actually abstracting away that call so that way it can do it and make sure that it always happens. So under the covers, it's actually trying to make sure, number one, that it's able to call that thing and it can retry it. If it fails, it can retry it. And it wants to complete it all the way through. It also allows you to scale this because now I can play, I'm not actually executing this right away. It goes on a queue. And when the queue picks up and it has availability, it takes it off. So it's automatically load leveling these so that you don't end up like burning out a bunch of processing. Okay, so let's take a look how this thing works. Don't know why that was important. Why did that fail? Because I probably left one. No. Did I click the wrong? Did I click the wrong one? Doubt. The demo gods are going to be bad today, aren't they? Oh, okay. I know what went wrong here. So it's complaining because this function right here, say hello, exists twice. So what I'm going to do real quick here is change. It exists in the one that I already created. And since I'm showing you again how easy it is, things aren't going to map exactly perfect. I think it might actually do it one more time. No, this one will be fine. Yay! All right. So you'll notice that we now have multiple triggers, functions that have triggers that are available to us now. We have the original one, our function one. We have the one that I wrote for this demo. We have the one that I just created, the HTTP start. And you'll also notice that we have the new orchestration hello, the say hello orchestration, which is the original, and then the two activity triggers. So this is that, when we go back to that diagram, we have those three portions that we were talking about. The client, the thing that's going to trigger or start it, the orchestration, new orchestration hello, and the final thing, say hello one in this case, which was the duplicate, the activity that's going to actually do the work, right? We didn't actually do any work in the orchestration. We just asked something else to do that work. Make sense so far? All right, so now we're going to take the new orchestration one that I just created. We're going to drop that guy over here into Postman. I'm going to create a new Postman tab. We're going to put it in as a get. We're going to hit send. But we didn't get back exactly what we thought we were going to get, right? We said the orchestration was going to return some these three values in a list. Well, one of the things about orchestrations is they're meant to be fire and forget. So as part of the durable function framework, what they've done is allowed you to fire and forget, but ask for the answer when it becomes available. So as part of this, we end up with I don't think you guys can see that, can you? Well, let me see if I can. Okay, is that better? Perfect, great. So as part of that, they give us a few of these URLs that are consistent for calling the framework. And one of those that's important for this case is the status query get URI. It's composed, it's an automatic webhook that it adds into Azure Functions that allows us to go and get the status of our orchestration. You'll notice as part of this, it says instances, and it gives us a long string in here. That is the instance ID of the orchestration we fired. So right now we have one that starts with B388. If I call it again, we're going to have 93112 this time. So now we've called our orchestration twice, but yet gotten a different callback. So every instance is going to give you a new instance. You can actually control that if you're expecting a consistent instance ID, like you want only one yourself, you can actually pass in an instance ID. If you don't give it one, it's going to always generate one for you. So now if I click that link, it's going to open up a new tab for me. And now our 93112 gives us back more information. It tells us, one, the name of the orchestration that we called, again, the instance ID that we called it with. It gives us a status. So what is the status of it? Because if you remember, when I talked about ordering a pizza, one of those steps was wait on the guy to make my pizza, and he has to click a button. So if that was the case, we would see, oh, wait, what's going on? All right. And I'm going to actually demo that to you here in a little bit. I'm just trying to give you an understanding of what you could potentially see. You could also have this be failed. So if there's a case of it's failed, or it could be queued up or terminated. So in the case like server shut down and it just terminated and you want to be able to restart it, there's all these different cases. So you can actually see what the status is of that. And then finally, we have our expected output, which was the list of hello Tokyo, hello Seattle, hello London, and then the amount of time it took, which was almost nothing.
So can I ask a question?
Yeah, absolutely.
So you're getting the best of both worlds by sending out a durable function into a stateless environment, and then you're getting the answer back if you want it. But how do you do a fire and forget?
Yep.
You're actually getting the answer back if you do want it. That's what you're showing us here. So you're basically using durable functions to take a sort of a stateful mentality in a stateless environment, getting the answer back if you want it. But sometimes you might not want it.
You may not need it. Exactly. Like placing an order, like you place an order on Amazon. If you successfully place the order, you don't care that they need to go check inventory. You don't care that their payment gateway might be down and they just couldn't even charge a card right now. So they're going to get back to you when they can figure that out, right? But all you care about is, can I place my order?
So you're sort of playing a stateless game with a stable orchestration to get the answer back that you want. Is that
kind of, yeah, exactly. And I'll show here in just a second.
Where is that data coming from? Is that data stored? Can you show us where that data is stored?
It's stored in the storage account. So it's basically like the abstraction underneath is storing it in the storage account.
It's more like
Yeah, I mean, I might be able to talk more about it afterwards, but I'll try and keep this one going. Okay, so he did point out something that I was just about to get into. So in this project, I'm not going to go into the total code about it, but I have this console application, which I need to go back and get the port number to make sure it's still the same. 729, it's not. When I developed this, one of the patterns that you can use is a asynchronous request reply pattern. So the idea behind asynchronous request reply is basically, I want to make a request. You're going to tell me that you accept it. And then I'm just going to keep asking you, are you done yet? And so basically, like, this thing can go and do work. Now, wouldn't be a good use case for this scenario, would be a good use case of a scenario where you're like asking for like a report to be generated and you have a API call you want to make. You're just waiting for that thing to generate the report. Might take 2 minutes, might take 10 minutes, and then finally be able to go maybe hit a download link or whatever. So that would be like something where in the UI, we would just be wanting to pull this endpoint over and over and over till it's done. I'll show that as an example because it'll help us demonstrate the next problem. So as part of that, we are going to start up multiple programs. Start demo 1 and demo 1. Perfect. All right. And now our function app has started again. I have this hit any key to start. I'm just going to hit it. Hopefully this works. So we can see kind of here in the background, some stuff happened and we got some output. Now, what you'll notice here is that the orchestration started and then we saw the final status was completed. So it kind of completed pretty quick, right? But what happens if it didn't happen really quick? What I'm going to do is modify the application now and just add some delay in there, just so we can see how that thing works. And a lot of this will make a lot more sense when I get to the final demonstration. So I want to go to, which one was the new one? I'm gonna delete this guy just because it's gonna throw me off a bit on the demo. Maybe it won't let me because I'm still running it. And so I'm just going to add a delay into my activity. I'm going to add it here because our orchestrations can't be delayed. They just orchestrate stuff. It's our activity that might really actually take a long time. So I'm going to change this to be an async task because we want it to be an asynchronous call. That enables me to do some asynchronous delays in there. So now I'm going to do await task delay, and I'm just going to put like 2 seconds of delay in there. So since I'm doing that, how long should this orchestration take to run roughly? I'm sorry? 2 seconds? Well, what does the orchestration do? 6 seconds, that's right, because we're going to call our activity 3 times sequentially, and we're going to wait 2 seconds before doing it. It's actually going to take slightly longer than that because the trade-off of putting things into a queue, waiting for the queue, drive them up, but that's going to be a rough estimate. So now, if I kick this off, we're going to see in the background, it's going to kick off 1. But now over here, it's just running. Are you done yet? Finally, it's done. Okay. So now we've been able to like wait for that response in order to continue on to our whatever our program needs to do. So that if we were talking about the report, it might be generate the link that the report's in a storage account or something. generate the link to give the client, and then allow them to connect to the report. Be kind of weird if they tried to get that report before it was done, right? They would get a 404 or something like that. Okay, but now we got an interesting problem. We waited 6 seconds. We have the same input to every single one of those things. Does it actually matter how long it takes? So if I said it takes 2 seconds for you to do it, and 2 seconds for you to do it, and 2 seconds for you to do it, would it matter who finishes first to say hello? Could I maybe organize them together? What would I need to do in order to make that take less time? So I'll try that question. Who thinks they know? Send them out in parallel, exactly. So the first concept that I talked about was function chaining, right? It's a sequential order of the things happening. But now what we want to do is talk about fan out and fan in. So this is the concept of saying, look, I don't need this thing. These two things aren't dependent to be sequential. Instead, if I send them all out at the same time, so this might be a good example if we were talking about real world is, what if I was doing shipping orders, right? You have UPS, you have DHL, you have FedEx, USPS, all different APIs, but does it actually matter that we do UPS first and DHL when you're just saying, I want to send a 2-pound package? No, not really. It actually makes more sense to say, hey, I got a 2-pound package. How much is that going to cost to send it so that I can get my answer back to my client at the same time quicker, right? With durable functions, the orchestration makes this super easy. So I'm going to show what that looks like. So now I'm going to stop my solution, and I'm going to go to the second demo. Or actually, I'll give a shot making the changes in this branch. All right, so we remember we have that 2-second delay. And so if I send it out in parallel, how long would we expect roughly for this orchestration now to take? 2 seconds. All right, perfect. So I'm just going to change a few things around here. I'm going to create a new list of task of string, because we're going to call all of those things asynchronously. Instead of putting the outputs directly in our outputs, instead, I'm going to take away these awaits, and I'm going to put tasks. Oop, what just happened? Something just happened. That was weird. Okay, there we go. So now I'm calling those tasks, but they don't actually start until we say await. So we still need to wait for them to happen. And we do that as simply as task.wait all. So when all of these tasks are done, what did I do wrong? New list of tasks. Not convert from tasks string to task. Yes. I did something wrong. Hold on. What do I do? What do I do? Demo gods. Thank you, demo gods. So awful. Real world problems, right? Okay, so we did a task of string. We have the tasks. We added the task to the string. Task dot. Oh, I did wait all and not when all. I think. There we go. My bad. Picked wait all instead of when all. So now when all those tasks are done, so basically what's going to happen is, this is more of like a multi-threading concept, but they applied it to activities and orchestrations. So that abstraction, what it's really doing is it's saying, go fire off, get Tokyo, go fire off, say hello to Seattle, go fire off, say hello to London, and it's putting it into storage. It's not actually executing. The engine is actually going to pick those up off the queue and start executing them as soon as it can. And so the when all is just saying, when it comes back, return them. Now we actually, those tasks are all ready to go. So one of the things you'll notice is this when all actually can return values directly out of it. So I'm going to take those values directly out of it. So we'll call it task outputs. And then with our task outputs, we just kind of want to add them there. Right now it's a string array. So instead of a string array, we want to return the list. So we'll just go here, .toList. And now it's the same thing. Does that make sense so far, what I've done and how I changed that? Okay, so now I'm going to execute the same bit of code. And ready? Yeah. And we'll notice that it fires all three of those, say hello, say hello, say hello. And then after the 2 seconds are done, it's almost done. So you can see this time, well, this is a bad example because it takes, let me try it one more time. Usually the first one's a little slower anyway. So now it only took 4 seconds, just at least proving that it took less time. So we're still paying the cost of putting it in a queue and it picking it up. If this was in a cluster of them and we were firing off lots of these, the payoff would be better. And we can, instead of trying to scale our application by just throwing money resources at it, we can actually say, you know what, 2 seconds is good enough. We can look how big is the queue getting and then decide whether we scale up and scale down based on that decision. So does how I did parallel make sense to everybody? Awesome. Any questions? Okay, cool. I'm sorry? Nope, all local. It's using a storage emulator and the Azure function is running locally. All right, so for the final part here, we're going to come back to our long-running application, right? We want our pizza guy to make the pizza, and so we need to send an order to the store. So we need a system that's going to support that. We also need to wait for when is the order going to get done. So for that, we're going to use events. So events are really just a simple way of saying, I'm going to wait for this thing to happen. So like if you're, you might be, there's situations where you might be trying to automate like a state diagram. You might be waiting for multiple events to happen. So you might be like, try and send off, do I have inventory, and do they have sufficient funds? And when I get any of those results back, go ahead and let me know, and I will check and see what I want to do next. So like if sufficient funds and we have inventory, continue the order. If we don't, tell them, sorry, we don't have the inventory, or do you want to wait to cancel the order? Or, hey, you didn't give us a good credit card number. You got to give us a good payment method first. So that might be that kind of orchestration where you're waiting for multiple kind of events to occur, but they're going to take a while to actually happen. So with our events, we're gonna go back to our code for the final part of the demo. This one, I'm definitely not going to recreate this one. There's a lot of code in this one. I just wanted to show a simple complex system. So I'll kind of break down what's in here. I have, this time I have 4 projects. The first one at the top is a Blazor app. So it uses Blazor and SignalR to be our pizza POS system. It has that same console app that we were looking at. It's going to just demonstrate that there's a long-running process happening. And then we have our function app, which is going to be running our orchestration, contacting our store, which is going to be the Blazor app. And then finally, there's a shared library in there. That's just to make it easy to have the same objects in all of those. So when I send the pizza order down to the other system, we're using the same classes to represent both. So I'm just going to first kick that off, and then I'll go into the code and show how it works. So bear with me just a moment while I set up for this one. Demo 3, demo 3, demo 3. So only 3 of those are actually runnable. The other is just a shared library. And now the screen sharing thing's in my way again. Why is it in my way? How do I get it out of my way? There it goes. Okay. So I'm going to get rid of these windows that are the completed ones from before that just didn't close. That's just like a personal preference thing when I'm normally developing. So we have our console app over here. So our console app now, instead of just saying hit any key, we now have the ability to order 3 types of pizza: Hawaiian, pepperoni, steak, and cheese. Sorry if I didn't pick your favorite pizza. We have our Blazor app here. So basically, if I go to this Blazor app, which I'm going to do now, I'm going to copy this and go to my browser. Oh, it's already started it for me. Perfect. So this is a out-of-the-box Blazor app. I just added some of the SignalR stuff into it. So if you click that, the counter, that's already there. I took the weather forecast page and set up our pizza orders, and now it's just waiting for orders to come in. Poor Mr. Mario, he really wants to start making some pizzas. And then finally, our orchestration app is up here. We have, so you'll see we have this order pizza orchestration, HTTP start. That's the point where I'm going to be saying, okay, go ahead and make me a pizza. So when I hit the console, it's going to say, hey, go start this orchestration for this kind of pizza. I have a activity for getting the order number. So basically, it's like, well, when you do that, we need to, give some information about the order, and we want that, we'll call it a sequential number for this thing, just for tracking purposes. We have our order pizza orchestration. So this is the thing actually doing the work of doing that. We're going to submit to the store activity. So this is what's going to call our API on our Blazor app and give them the pizza to make. And then finally, we're going to have a send notification, which really all I think it does is display something in the logs, because it really just didn't make sense to spend a bunch of time hooking up to another API for demonstration purposes. All right, so what I'm gonna do is I'm gonna leave this down. I'll snap it this way, and I'm gonna put, maybe it makes, with the screen real estate here, I'm gonna put this here, and put this roughly there. So what we're expecting to see, so when I click on this button, we're going to see the orchestration start over here. We're going to see the order pop up over here so that Mr. Mario can make it. And then what you're going to see over here is, again, it polling and saying, are you done yet? Are you done yet? Are you done yet? Okay. So I'm going to go ahead and order a Hawaiian pizza. And it's going to execute. We saw it pop up down here. So now Mr. Mario is going and he's going to make the pizza. You see here too that as part of the orchestration, the very first thing it did, scroll down a little bit more, is it called the order pizza orchestration. It went and got an order number. It then came back to the orchestration, and then it submitted to the store. So we got a good order number. Let's submit it to the store now that we have one, so that they know how to get their money maybe. Order 0 actually starts out the first one. If I do this another time, we'll see 1. And then now that now it's just sitting here and it's like, okay, well, the orchestration has succeeded up to this point. It's sitting there just waiting. It doesn't actually take up any processing or anything. It's just done. But over here, we can see it's in the running state. So what it's doing is it's waiting for that event right now. So I'm going to go ahead and say I made the pizza. So this enables it. And then bingo bango, you'll see here in the background, it the pizza made function was called. So I clicked that button. It called that endpoint that I enabled. It then said, okay, send the event to the orchestration using that client again. And then that let the rest of the orchestration complete. And then you can see the details of the instance ID that was completed. I ordered a pineapple ham and bacon, which is equivalent to a Hawaiian pizza. And then, so if I wanted to, I can do this again. I'll just do it a little bit faster without explaining it. And then I click the made pizza. We can see now, bingo bango, order number 1, just a plain pepperoni pizza. And then it's all ready. Yay! Congratulations. All right. So let's talk about the code. So what this will look like, that makes it different. So one of the things that you'll see in my demo is that I've broken out the orchestration and the activities a little bit. So a little going away from the, this is what you get to get started quickly, into a more like enterprise level, a direction towards enterprise level development. I have my orchestration in an orchestrations folder. I have my API in the pizza made function, or the pizza made function in an API folder. I don't remember why I didn't move the start, but I think I just got lazy. Because I would have probably, since that's an API function, I would have probably moved it in there, but keeping the two together isn't bad either. There's nothing that says there's any one way is better. It's just organization. If you're working on a team or whatever, it's just a different way to work. So we'll take a look at our how this works. Our orchestration basically said, take some input from our the pizza order. So basically when I call the API, we're gonna see that I'm able to place an order for a pizza. I'm gonna actually show this in Postman too here in a minute too, just to show what the console's actually doing. It calls out again, goes and gets our order number. It's passing our input, which is our pizza order. So it's just saying, go call this with our pizza order, get me an order number. Then when that comes back, I'm building up. Now I have my order number. So I got my order output. so now I have the request that I'm going to send out to the store. I submit this new request with, the important part here is the instance ID. So this is what it needs to know in order to call me back. So every orchestration has an instance ID. So we're just using that as a callback to myself. Hey, when you're done, tell me that the order's been made, reference this instance ID, and I'll complete myself. So we submit that to the store. Now it's been submitted via the API, sitting there, they're making it. And then here's the bread and butter of making this one work, this wait for external event. So basically what happens is the orchestration hits this point and it just goes to sleep. And until you hit this event, this orchestration will just sit in storage. It'll never complete it. It'll always say running, and it'll be waiting for that event to call back. Obviously, as part of doing that, like you may have logic where you may need to say like, give me all the orchestrations that didn't complete, like what's going on. There's still that part where failures can happen in other systems and those kind of things, but this is just very rudimentary, showing you all the possibilities. I'm not going into error handling and those kind of things, versioning, etc. And then finally, when that event does happen, we kick off our notification. And so I'll give you an example of the code that was written for the activity. Probably the one that I would do that's most complex is submitting to the store. So over here, we are basically making, we're just logging, hey, what's the submit to the store that I'm submitting it. We get an HTTP client. So I basically want to do an HTTP call. I want to get it from the client factory. I post that as JSON. So we're just saying, take my request that I want to send over, post it as JSON, and send it to this API endpoint. That's a lot. Does that make sense so far, what I showed? Okay. And then on the Blazor side of things, it's actually pretty simple. I'm just going to show only the event portion. So on the Blazor, we're saying, let's see. So I have this. So on the Blazor side, I have the API that I added for being able to accept an order. So API/order. So in that code, you saw API/order. That's what this is. It's just accepting an order, putting it into a service, and I'm just storing it locally, using concurrent dictionaries and queues to figure out which one's first and pull out the values. I was going to do a little bit more with it, but I just decided it was enough complexity as it is. And then the meat and potatoes of it being able to send to the UI, like, hey, I got a new order, update your screen, is this part right here. So the hub context clients all, it's saying, hey, let all the clients that are hooked up to this one screen know that I got a new order. And then there's some stuff for like the get orders. So that runs the screen when it goes and says, okay, hey, I got a new order. Let me get the list of all the orders. That's kind of what's going on there. And then the final part is the complete order. So we're now, we're just trying to make sure that we have the first order is the one that's the current one, and then dequeue it off the queue because we want to do the next pizza next, and then say, okay, create an HTTP client that calls our function app with pizza made and the instance ID that was passed to us in for this data. Okay, so like normally that part would be like the data, we would store that in maybe like a local database at the store or something like that. And then we would be pulling that back and forth from that. This is all just in memory at this time. And then again, now that we just completed it, an order, we want to update our order screen for the next order. And then, so now that process is just a nice simple loop there. And then, let's see, so I did that. Yeah.
So is the value of this, is that one value is you're stacking up orchestration without having to run them? And then you tie it to like data driven architecture, basically establish how you want to run your orchestrations. In other words, you don't have to run the orchestrations, you have to stack them up, use them whenever you want to use them. That must save a lot of processing time.
Exactly. You're not spending your time going, is it done yet? Is it done yet? You're kicking off, and when things need to do things, it goes, okay, here's an activity, go do it. And when all the activities are done, there's no more time to spend processing.
And then that gets tracked, and get tracked to like event-driven architecture. It's all queued up, set, maybe under another purpose, transactional or something.
Yeah, exactly.
And you'd say, I'm gonna just click it, and you say, okay, run.
Exactly.
And you can fan it, and you probably fan them all out.
Exactly. That's exactly the purpose.
Out of the processing.
So as I mentioned, I was gonna kind of just show like what this looks like. So I'm going to oops, I deleted the tab that had what I wanted on it. Okay, give me 1 second. Actually, I want to call this one, go to the top, 7034. I think this is correct. So I'll call this one, and then get rid of that. I'm trying to remember here. I think I get rid of all of this. Hopefully I'm right. So if I call it now, should have an, yep, there we go, perfect. So I just ordered ham and pineapple only with my API, and now I'm gonna do like ham, pineapple, and bacon, so that's a true Hawaiian. Now we have 2 orders over here, and now you can see like where I was saying it's single threaded for the pizza guy. So we're not watching the console anymore for like done pizzas, but we can actually come over here and just see that like when I click pizza made, we're going to see it send out a notification that the pizza was made. So store completed order for pizza order 2. And then now we're going to do pizza order 3. We'll see that kind of down here. And there you go, store completed order for pizza order 3. So kind of just tying that whole thing out, how is it working? And so it's just, all it's really doing is calling an API, says go, this is the event that's being driven to it. And then it wakes it up and continues on. All right. So one of the things I did mention during the demo was just a little explanation of like the determinism and a few little things that are important key concepts around the orchestrations. Number one, I would highly recommend like looking at the documentation for this stuff. It's actually pretty good. It does take some time to go through their demos and stuff, but digging into it, they explain like all the important concepts. I'm just going to get into a couple that are really important. So one of the things that I mentioned is deterministic functions. So if you think about logging in an orchestration as being deterministic, means that, I do want to show you one other interesting thing. I'm going to set a debug breakpoint, and this might help to kind of explain how it works. So up to this point of submitting to the store, we're going to submit one order. And then you'll see I hit this breakpoint. It's going to send it to the store. But wait, it hit it again. That's weird. Then I'm going to come back here. I'm going to hit pizza made. That's weird. It came back to submit the store or submit to store. And then we're going to see it go. I'm going to hit the breakpoint right here. And we're going to see it hit this breakpoint. Underneath the covers, what's really actually happening is at every one of the steps where an await occurs, it takes all of the things it did, replays every single one of them, and stores all the values of inputs and outputs as it's going through here. So what it's doing under the covers is saying, okay, you did this, and you got this value, run the code again, now with this value. So it's basically just saying, okay, what was the value given to me at this point? Make sure you return that. So that way your orchestration is basically playing through, it's replaying your orchestration every single time. This is a concept called event sourcing. So event sourcing underneath the covers, it's keeping a log track of everything you do in there and making sure that it happens in the same state. That's what actually makes the orchestration work so well. So if you do anything where you like go and get the time from a server and you try to put it in this, it's going to freak out, because if you pass that time to the next thing and now the time changes, it's going to throw back a non-deterministic error to you. So where we have this create replay safe logger in here, the reason for that is because it's acting like a logger, but it's keeping track of what you logged as part of the orchestration's data underneath the covers. And so basically as it goes through, it says, okay, you got to this step, what's the next await that you haven't done? And as long as you go through that orchestration every single time, it goes, okay, no problem. And then it plays it through all the way through. Okay. So let me go back to the slides. Kind of in summary, like this is really great for, automating some really complex orchestrations. We use these at Jackson to orchestrate a checkbox, believe it or not, and some really complex orchestrations to do those, because we have lots of different systems. They're all expecting that might have different domains of data. We need to bring them together. We need to let different systems know about things and check them in different places. But some of those actions are always the same for the same activities. So how you do a trade or something like that is always going to be the same regardless of what you do. But we need to do different things for, like, what happens when the trade doesn't work. Well, we have manual processes maybe, or something that run those kind of things. And so this helps to automate all of those different processes. One of the things is just using events to model asynchronous processes. So like that's your manual steps in your process. So when you need to put a human in touch, that might be something like you're doing order inventory, is like, hey, did I scan the barcode that has the order number that I'm expecting and complete this portion of my order out? We can now store that, send it back. Hey, this part's done. Okay, great. Let me check that. You might have that same event with just slightly different data, and like you might just say, okay, I got one, and you continue to like pop off the queue essentially till all of your order is done, and then you continue and you say, hey, your order's been shipped. And then on here, I have just some really good resources. I literally put the durable functions overview. It explains all these things way better than I ever could. go through the develop portions, go through, do the demos. They've got lots of great examples. They have them in multiple languages. So if C# isn't your thing, go try the TypeScript one, or Java, or whatever floats your boat. And then another thing here is this durable functions monitor. I didn't install it on this, just takes a bit of time, but it is definitely a cool tool that works with the durable functions. It creates a web page that allows you to like restart a workflow or start your own workflow and just pass in data, look at where it is in the steps, debugging tools. So any errors that are logged, that kind of thing, pops them up to the top. Allows you to search by dates. Like, so if you've been running these workflows for years, you can like literally go through years of data and just like look at what happened. Yeah, that's all I got. Really appreciate everybody showing up tonight. My name is Chris BERTHOLD, and I'll be happy to answer any questions you have.
So first off, so durable means that it's storing the state, not the function itself, but somehow hardened.
Yes, exactly.
How does this compare?
Okay, so AWS, great question. Okay, so AWS Lambda functions just in general are stateless. So that would be Azure functions in general. What you would actually be comparing this library to is Azure step functions. So where the difference is there is that while step functions they're not code like this, they're code in JSON. So they're pretty complex. You end up having to you don't have any tooling that really helps you get it right. And the workflows can't do like stuff like this where you really want to get in and you might have algorithms that you want to just pump in. You actually still have to put those off into another spot, and it becomes far removed, right? You have the functions over here, then you have the step function over there. The code's not really together. It's kind of complex to pass. You saw I did some basic object manipulation directly in the orchestrator. Stuff like that's okay to do, but you can't really do that as easily in the step functions. It's just indefinitely. Indefinitely. Yeah, so yeah, exactly. So you might have cases and versioning, when you talk about indefinite orchestrations, you're definitely going to want to learn a lot about versioning, because eventually you might need to change something. And so that deterministic function needs to still happen in the same way. So if you make a change to one of these, it needs to still work exactly the same, except for the one thing that you want to do has to happen after, or it needs to handle for those situations and know. So you have to add information to it to help you identify when can you do that thing. But it is possible to do an infinite time workflow where it's like, I don't know, I want to collect information from all of my workers and make sure it's always done, kind of thing. It would think automation, like something you want to do endlessly. So I want to check every day at 3 o'clock that this set of steps has happened. If not, run this workflow, kind of thing. Possible to dynamically create an orchestration at runtime. Yes. You're really just getting into passing generic, looking up generics and calling those functions in a particular order. So you still need your dynamic portion would need to handle the branching logic for that thing. But if you did have something that was probably a little more sequential, you would be able to do that. I think the thing to keep in mind is, like, what I'm trying to think about is you'd have like an overlaying orchestration that's able to look up the same orchestration as last time, because it needs to make sure that it has those same steps. And then it needs to play back those steps to another orchestration. So you're getting into like sub-orchestrations, which totally can do with this. They have a whole nother tab on. I mean, you're basically just going through a loop of instructions or a hierarchy of instructions. So you're going to put that whole code in dynamically. I think if you were getting to that, doing something like that, I would probably go the low code, no code, potentially. That's a edge case that I've never tried it, so I probably wouldn't suggest trying to do something quite so dynamic like that, but I think it's possible for sure. So you're asking, is the orchestration a new concept? That is a definite no. So BPM is an example of like orchestration. Been in the Java world for a very long time. This is just kind of their way of making orchestration simpler. So like, I think the language was like BPML is like the overarching domain specific language for BPML, BPEL. I don't know, it's been so long. That basically tries to do that same thing with XML. So kind of generating an orchestration with XML that turns code and does the same thing as like, this is just a very code specific. What's awesome about it being in code is when you're testing, you're just testing a function like no different than any other function. So it's super, super unit testable, which makes, you know, like if you're able to build good unit tests around these things and make sure that you're testing your various scenarios, boom, you're done in like no time. As far as simplifying it even more, that's a hard question to answer, because I mean, like, some of our workflows are like so snaky, complex with if this then that kind of situations that like the BPM of the same thing just becomes snaky and nasty, like looking at the XML and when there's a problem or debugging. Like, this is so simple. You set a debug point. Like I showed you, it can hit the same debug point a couple times. So you kind of like gotta know where it's going to probably hit and work backwards from there. But like, it doesn't get much simpler than that from my perspective. Any other questions? All right, well, thanks so much, Sorella. Back to you.
I have a message from Emily online. Say, I don't know how people's brain works so well at the end of the day, but great presentation. Thank you, Chris. That's what she said. Okay, so for the ones that are new, we usually have a tradition after the meeting. We like to all go and hang out together. We go to the little courtyard in downtown Fort Myers, which is right behind the pizza place. So if you would like to join us, please stay here. You can leave your car here too. It's totally fine, because I think now they're charging parking at downtown. I don't know if
You can walk, right?
Yeah,
it's like walk. We usually walk and leave the cars here.
Walk, have pizza, beer, and walk back.
So it's 8:30 right now. Yeah, it's 8:30 right now. We are going to stay here in this room for another 10 minutes, and then we're all leaving. So thank you. Yeah, stop sharing. Okay. And if you want to be on Slack, or if you want to join our Slack, just come to me like an address.
And if anyone's asked,
Thank you, everyone. We're closing soon now. Thank you. Bye-bye.
I don't bite.